You know, if you break your arm, an X-ray shows this jagged line.
Yeah, it's super clear.
Exactly. It's binary. It's broken or it's not. The doctor points to it, you see it, and it just makes sense.
Right.
But what happens when the diagnostic machine is like an AI that is quietly learning to discriminate against you? And literally no one, not even the brilliant engineers who built the thing, knows how to actually read the results.
That is, well, it's the terrifying reality of the black box.
It really is. So welcome to today's deep dive. Our mission today is to decode this comprehensive slide deck we've got. It's simply titled Day 1 AI Ethics.pptx. And we're looking at why AI ethics is no longer just this, late-night philosophical dorm room debate.
Oh, it's really not. I mean, it has absolutely become a do-or-die business survival skill.
Yeah.
Because if we look back at, say, the 2010s, the big cliche was that data was the oil of the economy, right?
Yeah.
It fueled everything.
Right. Data is the new oil. We heard that everywhere.
Exactly. But the deck we're analyzing today makes this brilliant pivot. It says that in the 2020s, artificial intelligence is the ballast driving economic growth.
The ballast. I like that.
Yeah, it's what gives the ship its stability and its momentum.
And obviously, if you don't build that ballast correctly, the ship capsizes.
Mm-hmm.
So for you listening, we are going to look at how AI actually thinks behind the scenes. We'll walk through a spectacular real-world AI failure, one that cost a company its entire reputation overnight, and explore how nations and boardrooms are just desperately trying to put guardrails on this technology.
Which is so needed right now.
Right, because before we can even talk about governing AI, we have to understand how it makes decisions, and more importantly, why those decisions can be wildly, hilariously, and sometimes dangerously misleading.
Yeah, and to understand that, we kind of have to skip past the basic definitions of machine learning. Like,
Yeah.
you already know these systems use probabilistic models based on massive data sets, right? They require strict human oversight. But the real issue, the actual crisis, really, is what happens inside the deep neural networks, like the hidden layers.
Okay, here's where it gets really interesting for me. Because you assume that if you feed like millions of images into an advanced neural network, it learns like a human does, right?
You'd think so, yeah.
Let's look at the Pascal VOC dataset from the deck. This is a classic dataset used by researchers to train image recognition software.
Oh, the horse example. This is classic.
Yes, so they asked the AI to look at thousands of pictures and identify which ones contained a horse.
And the AI successfully flagged the photos with horses in them. I mean, it performed flawlessly.
100% on the test.
Exactly. But when researchers finally dug into the hidden layers to see exactly how the AI was weighting the pixels to identify the horse, they found it wasn't looking at the animal's legs at all.
Wait, really?
Yeah, it wasn't looking at the tail or the mane or the shape of the head.
Hold on. The AI ignored the horse entirely. How does a machine that complex miss a giant animal taking up the whole photo?
Because the machine doesn't actually know what a horse is. I mean, it only knows patterns of pixels.
Right.
So the AI had realized that all the photos of horses in this specific data set happened to be provided by a specific photographer.
Oh, no.
And every single one of those photos had a copyright watermark in the bottom left corner that said Lothar lens.
Okay.
Nope. The neural network simply learned to scan the bottom corner for that specific pattern of pixels. If it saw the Lothar lens watermark, it basically said, yep, that's a horse.
That is wild. It just completely bypassed the actual assignment.
Completely.
And there's another incredible example in the research regarding boats. Researchers trained a system to identify boats. But instead of learning to recognize, a wheelhouse or a sail or the bow of a ship, the AI just looked at the background.
Right. It took the easy way out.
Yeah, it learned to look for a non-specific mass of pixels in the middle of a picture that was surrounded by a textured blue background, which it statistically correlated with water.
Exactly. So the texture of the water became the defining feature of a quote-unquote boat.
So if you put a picture of like a floating armchair in the middle of a lake, the AI says, yes, a fine vessel.
Pretty much.
I love this because it perfectly illustrates a concept I've been thinking about. It's like comparing the AI to a brilliant but incredibly lazy student.
Oh, that's a great way to put it.
Right. You give this student a massive multiple choice test instead of actually studying the material, like learning the biological features of a horse or the maritime engineering of a boat. The student just realizes that every time the answer is C, the font is slightly darker.
Yeah, they just look for the pattern.
Exactly. They ace the test, they get 100%, but they haven't learned a single thing about the subject matter. They just gamed the system.
What's fascinating here is that this lazy student behavior is the absolute core of the explainability problem.
Right.
Explainability and interpretability are, frankly, the massive hurdles in the tech industry right now. Because if you feed data into a black box and it spits out the correct answer, you might be thrilled initially.
Sure, it looks like it works.
But if we don't know how the AI got its answer, if we can't see that it's cheating by looking at a watermark or, the texture of the water, we cannot trust it.
Because things change.
Exactly. The minute you give it a picture of a horse out in a field without that watermark, the system completely fails.
And we need to remind you, the listener, why you should care about this. Because we aren't just talking about a machine failing to recognize a pony on the internet.
No, the stakes are much higher.
These exact same black box systems, these systems that take the path of least resistance, are making decisions that affect your finances, your mortgage applications, and your career.
Which brings us to the very real stakes of this technology. I mean, if an AI will cheat at recognizing a horse by taking a statistical shortcut, what happens when that exact same underlying architecture is put in charge of deciding who gets hired for a job?
Okay, let's unpack this, because this is where the theoretical leaps right into the practical. The deck shows how AI is already heavily deployed across the entire hiring pipeline. It's not sci-fi, it's right now. And it's not just keyword scanning anymore.
Not at all.
Take a tool like Textio. It uses AI to write job adverts designed to appeal to a broader range of people. It analyzes the subtle, subconscious biases in language.
Yeah, like the tone of the ad.
Exactly. It might flag words like ninja or dominate as statistically deterring female applicants,
Right.
and suggest more collaborative language instead.
And that's just at the top of the funnel. But as you move deeper into the hiring process, it gets much more complex.
Yeah.
You have platforms like Pymetrics, which administer these AI-driven, gamified neuroscience tests.
Gamified tests.
Yeah, candidates play these quick little digital games, and the AI measures their risk tolerance, their memory, and their reaction times. And then it compares those traits against the company's top performers.
Wow. And then there is HireVue, which conducts video interview assessments. The AI actually analyzes a candidate's video responses, but it's not just transcribing what you say.
You're right. No, it goes way beyond that.
It is analyzing facial movements, eye contact, and vocal intonation to assess your employability.
It's intense. And don't forget the sourcing side. Companies like Korn Ferry utilize AI recruitment software to literally scrape the entire internet.
Just trawling for data.
Exactly. Trawling public data to find potential candidates who might not have even applied, predicting who might be open to poaching based on their digital footprint.
Here is my pushback on all of this, though. We tend to have this, blind faith in machines. We think, well, a computer doesn't have a preconceived notion of race or gender, so it's perfectly objective.
Right, the myth of the neutral algorithm.
Yeah. But if these AI models are trained on historical data generated by biased human managers making biased hiring decisions over the last 50 years, aren't we just automating our past prejudices at lightning speed?
That is the exact mechanism of the risk we are looking at. The AI is that lazy student again. Let's say it looks at 50 years of hiring data for a prominent engineering firm. It notices that the vast majority of successful long-term hires were men.
Okay.
The AI doesn't know what sexism is, doesn't have a political agenda, it just quietly decides, statistically, being male must be the key feature of a good engineer.
Oh, wow. Just like the watermark on the horse.
Just like the watermark, it finds the shortcut.
So a system like HireVue, analyzing facial expressions, if it's trained mostly on neurotypical Western candidates, how does it score a candidate from a culture where direct eye contact with an authority figure is considered disrespectful?
Or a candidate on the autism spectrum.
Exactly.
It scores them poorly because they don't fit the historical pattern. And this is seeping into incredibly sensitive, life-altering decisions like your livelihood, your freedom, your well-being, much faster than consumers even realize it's happening.
And when a company gets this wrong, when they deploy a product without establishing how the AI is actually weighting its decisions, it isn't just a quiet glitch in the IT department.
No, it's public.
It can be a massive, explosive disaster.
Which leads us to a fascinating case study from the deck. This is a perfect illustration of what happens when the lazy student AI hits the open consumer market without any ethical guardrails.
Let's talk about ScatterLab. This is the tech company in South Korea. They had this popular app called The Science of Love.
Oh, this story is wild.
It is. The premise was that you could upload your actual real-life chat histories with your romantic partner from KakaoTalk, which is basically the dominant messaging app in Korea,
Hmm.
and the app would analyze the degree of affection between the two of you based on your text patterns.
And through this app, ScatterLab managed to harvest an astonishing 10 billion private messages.
10 billion people were just handing over their most intimate conversation.
Yes. They then took that massive data set of 10 billion unfiltered human conversations and repurposed it to train a brand new chatbot, an AI named Luda Lee. Okay. They designed Luda to interact like an ordinary 20-something